Hello, geometry students. I am live in studio at St. Peter Church and School on 1250 South Shore Drive. Looking to have a great geometry review session right now. Unfortunately, all my erasable pens are at home. Didn't see that one coming until I sat down to do this. Anyway, it's just 4 sides. This shouldn't take too long, but it is important you get the concepts. So an adult female panda weighs 200 pounds. Its newborn baby weighs only 1/4 of a pound. What is the ratio of the weight of the adult to the weight of the baby panda? Oh, one moment, please. Okay, it's from Columbia, Canada. No, Vancouver, British Columbia, Canada. Don't know anyone there. Okay, so we are going to take and do 200 pounds over 1/4. Panda over baby. Now, you can't just leave it looking that ugly. So in order to get rid of the fraction on the bottom, you just multiply top and bottom for the ratio. And we're left with 800 to 1, or 800 to 1, or 800 to 1. And no, it does not mean the baby's 800 pounds. Oh, help me. It means that the mom is 800 times bigger than the baby when the baby is born. So when the baby is just 1/4 of a pound, like that's craziness. And this big old giant panda weighs 200 pounds. The difference is 800 times that amount. Okay, so there you go, and that's that. So just remember to look for, where is that key word, to weight of adult to weight of baby panda. I recommend you always circle the word to. It really will help things jump off the page. All right, the lengths of the sides of a triangle are an extended ratio 4 to 7 to 9. The perimeter is 60. What are the lengths of the side? So that means that they're in proportion, this amount. So if I multiply this by 10, this by 10, this by 10, they're still in the right proportion. Or if I multiply this by 20, this by 20, this by 20, it'll still be in proportion. But I want to hit a perimeter of 60. So I'm just going to call it X. I don't know what it will be. I just know it's going to be the same for all of them. So I'm going to call it X. And it's equal to 60. And then I'm going to just go ahead and add all those together. And let's see, what is that? 20X equals 60. Divide by 20. And X equals 3. Now let's make sure we answer the question. What are the lengths of the sides? Okay, that's plural. That's everything. So we've got one length is 4 times X. So 4 times 3, 12 centimeters. The other side is 7 times X. So that's 7 times 3, 21 centimeters. And the third side is 9 times X, or 9 times 3, which is 27 centimeters. Let's just hope they add up to 60. Yay. Check. There's my 3 sides. So we're going again with this extended ratio, and it says now this ratio for this triangle was 3:4. It's that the length of the shortest side is 6, and they want you to figure out what the longest side is. Okay, so when you look at these 3, the shortest one is right there. So that ratio, 2 times whatever, is 6, because they just said here the shortest was 6. So when I solve that and get 3, now I know the variable that it grows by. It grows by 3 times on every side to get the 6. So now I go and it says the longest side. So I look up here and I see, okay, the 4 is the longest. So I'm going to do 4 times X and see what that is. And I figured out X from this other side here. It has to be the same as 12. centimeters. Proportions. I think you're all pretty good at this. The only one I would see any problem with is this one over here, but hopefully none, no problems. 4x equals 84 divided by 4, x equals 21. 70 equals 20x divided by 20, x equals, the zeros cancel, so 7 over 2, 7 divided by 2, 3.5. And yes, you could have left it as 7 halves, it's fine, but now here's a little trickier. So when you do this cross multiplying, remember the 5 has to be multiplied by both. It's distributive. 5x plus 25 equals 7x. And we got to get the x's on the same side. And we get 2x. Divide both sides by 2. X is 12.5. So just go, just be careful you don't make little errors there. Those should be ones you like to see. Okay. Are these polygons similar? Okay, well, in order to do that, number one, I see that the angles are all the same. So I have all congruent angles. So the first check is in place, but all the sides also have to be proportional. So let me check. So 5 over 10, 3 over 6, I'm checking, 4 over 8, and 7 over 14. So I got to check all those. 1/2, 1/2, 1/2, 1/2. Check. All sides are proportional. So yes, it is similar. Are they similar? Yes, they are similar. If they are, write a similarity statement. Okay, it's not a triangle, so I'm not going to put a triangle in there. I'm just going to put letters. So I'm going to do KLMN. KLMN. I'm going to remind myself what direction I went. KLMN. I'm going to go over here. QRST. QRST. Similar and done. No, not done. And give scale factor. Okay, we already did that. It was this, but simplified. So it is 1/2. Now, it doesn't say which way to go. So I kind of did these going this direction. And since I didn't tell you, I would accept either direction. If you had 2 to 1, that's fine too. And let's keep reading. If not, well, it isn't explained. It is, so we don't have to worry about that. Okay, on a map. The scale of a map is 1 inch to 25 miles. Throw it in a fraction. On a map, the distance between two cities is 5.25 inches. What's the actual distance? So we're using a map and we're like, okay, every inch on that map is 25 miles. On the map, it was 5.25. So make sure you put the 5.25 inches on the same level as the inches. You can't put it down here. Same. Now we figure that out. So we cross multiply and get x equals 25 times 5.25, and our answer is 131.25. What's our unit? Miles. Good. We're moving right along. All right, so now we have two figures that are similar. They're sitting the right direction, so that makes it a little easier. And it wants to know what the value of x is. Okay, so we just have to set up a proportion there. And we can start with the variable if we want. X over, what's the corresponding side? 5. It's equal to, go back to the one with x, 18, over its corresponding side, 12. And more proportion solving. 12x equals 18 times 5 is 90. Divide by 12, and it should come out to 7.5. Do we have a unit? No. I'm just going to write UN for unit. All right. Determine whether the triangles are similar. If so, write a similarity statement and name the postular theorem you used. If not, explain. Okay. So the definition, if we were going to ever show something by the definition, which it doesn't actually say definition in here, you'd need all sides are proportional and all angles are equal. But in here, they're looking for all the ones we learned, the SAS similarity, AA similarity, SSS similarity. I think there was a HL similarity as well. My little brain cannot remember if it was, if we had that yet this chapter. It's not on here. So here's sides. So you got to be careful and make sure you put the right ones together. So I always just start with the smallest. So here's my smallest one here, 9, and I go to my smallest one on here, which is 15. And I check to see if that's equal to my next smallest, 12, over my next smallest, 20. And I check to see if that's equal to my biggest, over the biggest. And when you do simplify these all, they all come out to 3/5. Divide these by 3, divide these by 4, divide these by 5. And it comes out to 3/5. So yes, all the sides are proportional. So that is our SSS similarity theorem. And then don't forget, it says write a similarity statement, name the theorem. So there's two things. I named the theorem, but I did not put a similarity statement yet. So I need to do that. Triangles. So I'm going to get it set up there. So let's see, triangle. I'm going to just start here and go over the short, medium, and long side so that I can keep track. QSL. QSL. And now I'm going to go up to the small, and then go over the medium. So I'm going to go over the small, RNT. Done. When you look at the next one, see here. Well, we're dealing with, excuse me. Oh my goodness, nap time, I guess. Angles. How many angles do we need to have a similarity statement? 2. Okay, so right now we have 1. We have 64. And that's 90, but we don't know that one, but we can figure it out. So we can see 180 minus the 90 minus the 64 comes out to 26 degrees right here. So that is enough work for me to determine, and you could figure out that one too and figure out that's 90. One way or another, you figure out that, oh good, ding, 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 ding. I have 2 angles in each that are the same. So it's angle similarity theorem. And then I have to do my statement, and I'm going to write everything really clear so I don't forget, like on the other test where people were forgetting. And we need to put it in order. So I'm going to start with my 26 degree angle. MBD, MBD, FWY, FWY. And again, yours could be different than mine, but just check them. So if you said BDM, then look over here, it should be WYF. So they just got to be on the same position on both sides that I have them. So if you have wherever you have your M, you should have your F. Wherever you have a B, you should have your W. Wherever you have your D, you should have your Y. So you can check your answer. Okay, looking at this. Looks like we have 2 sides. Do we have any angles? Okay, if we knew these were parallel, we would have alternate interior, but we don't know they're parallel. So the only thing I know is that these angles are the same, vertical angle theorem. Now, I want to take you to take note of this, because at first when I was looking at this, I saw this 9 up here and thought it was that side, but notice where the arrow is pointing. It's pointing to that other side there. So that is just slightly confusing. So I'm going to sneak the 9 in there just so my little brain doesn't get confused. And now I'm going to try and see if there's proportion. 6 small over the small up there. Is that equal to the large over the large up there? And let's see, divide by 3 and you get 2/3. Divide by 5 and you get 2/3. So check. Now, is the angle that's the same between those sides? The answer is yes. It's right between the 2 sides. It's between these 2 and these 2. So we have SAS. Remember, the angle has to be between them. Similarity theorem. And I now have to draw my thing. So I'm going to start with the small side again, then go to the middle. GRP, GRP, NRK. All right, let's go over here. So these are isosceles triangles. I can tell because these sides are the same and these sides are the same. And this is 36, so I can figure these out. When I take 180 minus the 36, I get 144. And then when you divide it by 2, I get 72. So this is 72, and this is 72. And this is 71, and this is 70. I can figure everything out here almost. And then when you add those two up, you get 142. And when you take it away from 180, that's 38. But it doesn't even matter, because even though these two sides are equal to each other, it's irrelevant. Because, well, number one, the included angle isn't the same, 38 and 36. But number two, the sides aren't even proportional. The fact that these are equal isn't the same as this is equal to this and this is equal to this. Remember, SAS means you have proportional between them. Okay, I can't say these are proportional because all I know is they're the same in that triangle. Okay, but even so, the included angles aren't the same either. So, no, and I would just say one of those ideas. So included angles not congruent. Although now I'm thinking about it, and if these are the same, actually, and these are the same, this over this should be equal to this over this. So now let me rethink that, because I actually believe that was incorrect logic there. If you knew these are the same and you knew these are the same, this over this would be equal to this over this. So nope, the only answer would be the angles, included angles are not the same. It actually could have been used for SAS, the sides. I wonder who picked that up out there. You'll have to let me know. All right. Oh, good old Mrs. Silva, 6 feet tall. She's in her pink. And she is casting a shadow. Wait, how tall am I? 6 feet. Casting a shadow 3 feet. At the same time, there's this beautiful tree. It's the only thing I can draw is trees. And they're always so cute. And it casts a shadow of 18 feet. How tall is the tree? That's my x. So I've got a proportion. So you can do Mrs. Silva's height over the tree height is equal to shadow height over tree shadow. Or you could have done my height over my shadow, tree height over shadow. What you basically are looking for is when you, if you have a proportion here and you want to see if you set it up right, see if the x and the 3 are across from each other. Even if it's this way, it doesn't matter as long as they're across from each other. The x and 3 should be kitty corner. 3x, because then right now you'll get the exact same thing I get. I don't know what 6 times 18 is. Tree is 36 feet tall. All right, on to the third page. We're moving right along. Remember, in a geometric mean, when you see geometric mean, wah, wah, that is a proportion, and in that proportion, this is the geometric mean. It appears twice. So when it says find the geometric mean, that means this is the starting point for both of these. And I shall now switch colors. I'm officially sick of the pink. So I shall pick this beautiful blue. There we go. And I give you the two numbers, so you're just going to pop them in there. Same thing for both. Cross multiply, x times x class. You know this, x to the second power. It's not 2x. 9 times 25, 225. So to get x alone, we square root both sides, and it's a cool deal because this one works out evenly. Comes out to 15. This one, on the other hand, x times x is x squared equals 120, and you square root, does not we have this. And I don't want a calculator. I want an exact answer, and I want it in radical form, reduced radical form. So I want you to, again, think of something where they multiply to give you this, but one of them has to be a perfect square. So in other words, you can take a square root of it. It comes out even. And that would be 4 and 30. Because what's the square root of 4? 2. So that pops out. The 30 stays inside. He's stuck in there. He's stuck in the jail. He can't get out because he's not a perfect square. All right. A pie shop sold a total of 117 pies one day. The pies were, let's just keep this straight, apple, cherry, blueberry. The ratio of apple pies, here we go, apple pies to, I want to get that 2 in there, cherry pies to blueberry pies was 6 to 2 to 5. For clarity's sake, I'm going to come down here. The 6 was which one? Apple. The 2 was which one? Cherry. The 5 was which one? Blueberry. How many cherry pies were sold? So ultimately we need this one, and the answer is not 2, right? This is all a ratio. But we have it equaling 117. That's the total. So this is where you can put the x in there and set it equal to the 117. It was like the very, where was that one? Number 2. It's just like number 2. So when you go ahead and add these all up, you're going to get 13x equals 117. X is 9. Now that only helps because I need to be able to go back now and find out cherry. You could find out all of them, but this was my apple, this was my cherry, and this is my blueberry. So for cherry, 2 times x, which is 2 times 9, which is 18 cherry pies. If I wanted apple, I would do 6 times 9. If I wanted blueberry, I would do 5 times 9. And then when I added them all up, I should get 117. All right, number 18, write a similarity statement relating the 3 triangles in the diagram. So remember, any right triangle, when you put an altitude, you get 3 similar triangles. So let's set it up first. Whoa, what the heck did I put that sign there for? I derailed. Come on now. There we go. Similar to triangle. Similar to triangle. Now, I recommend when you're doing this so you don't get mixed up to have like a pattern. So, for example, I'm going to do go across short, go across long. So I'm going to start with this big triangle. Uh-oh. Everyone's getting out of school now. It's going to get loud. Uh-oh. Hopefully you can still hear me over the loud crowds in the hallway. Okay, so we're going to start with this big triangle. So I'm going to look at this one first. So everybody focus in on this. Short, long, hypotenuse. So I'm just going to focus on the short and the long, the 2 parts that come together in the 90. N to P to O. Then I'm going to look at, let me get another color. A moment, please. I'm going to look at this little guy right here. Okay. This is the hypotenuse. I'm not looking at that right now. I'm going to start with the short. N, R, P. Now, I shall get out my green. This is terrible. What kind of pen is that? I hate this green. Okay. So on this triangle, this is my hypotenuse. The right angle's here. So I'm going to go over the short. P, R, Q. Now, I suggest when you're done, you just double check. So look what I do. I'm going to look here at my big triangle, NPO, this big one. And I'm going to look at the NP. Yep, this is my short leg. And then I'm going to look at PO. Yep, that's my long leg. And then N, 2O is my hypotenuse. It's across from the right angle. That's my hypotenuse. It should be the same for all these little cute little smiley faces. Okay, look at the little purple one. N to R, yes, that's my short side. R to P, yes, that's my long side. And N to P is my hypotenuse. Oh, it's so cute. Okay, then I look at the green. P to R, yep, that's my short side. R to Q, there's my long side. And P to Q, that is my hypotenuse. Yay! This should be right. All right, find the value of x. So if we're trying to find the value of x, remember there are two areas that are means. So the y is a geometric mean to 5 and x. 10 is a geometric mean to 5 and this whole side. So if I'm going to find x, I'm not going to use this as my geometric mean because then I have two variables. Right? If I set that up and put the y in there twice, setting up a geometric mean like this, I'm going to end up with x in a different spot. There's no way I'm going to solve that. So I'm going to use this one as my geometric mean. And that's important to know because that's the one that goes in there in two places. So you're deciding this or this. Now, what's it a geometric mean to? It's the side that touches it, the little one, and the whole side. So you got to put those together, and they're not multiplied, they're added. X plus 5. Cross multiply. 100 equals, don't forget to distribute, people, 5x plus 25. And we are going to solve. And then we are going to divide and get 15 for x. And we're done. Again, what's the value of x? Now this is that other theorem, remember, where this cuts through and this is the same and this is the same. And when we have that angle bisector one, it was that one where we can leave it so it looks like a fraction. X over 9, like a fraction, is equal to 25 over 15. So x over 9 equals 25 over 15. 19x equals, is that 225? I'm not sure. Yep, 225. Divide both sides by 19. And x is, see? Whoa, something's wrong. Something is very, very wrong here. Oh, you guys saw it, didn't you? Where's my whiteout? X over 9 is not equal to 25 over 19. It is not a 19, people. I'm glad you were yelling at me because I'm sure you were. So this would not be, this would be a, I'm glad it's the number I wrote 100 times so I can write it all out. All right, so x times 15, divide by 15, divide by 15, and actually you get 15. So we found it. All right, great job, great job. We are going to move on now to the very last page. And we're finding the value of x. So when we do this, first you want to kind of look at it and say, oh, well, could I do, geometric mean, or could I do Pythagorean theorem? So it depends what you're looking for. I want that. So if I want, I don't have that, so it's hard to get that. I could get that. I could do Pythagorean theorem and get that and then do that as the mean, so a geometric mean. So I could do it that way. Or I can notice that I have this side and I could do that one as the geometric mean. So I'm going to do that instead. Either way will get you the right answer. 6 and 6, and then the side closest is 3, and the whole side is, again, adding x plus 3. You are going to cross cancel. We have 36 equals 3x plus 9. I'm going to subtract 9. I'm all right, people. My nose is running as usual. X is 9. So if we have time, as a bonus, just for fun, I'll go back and do this the other way. Now we got the side splitter. Remember what the key thing was, is that these were parallel, and they are, so that's great. That means that it splits the sides proportionally. So I can do 5 over 8, literally, equals 4 over x. Make sure you go in the right order. Cross multiply, 5x equals 32. Divide by 5, divide by 5, and x is 6.4. Okay, and this is just another one of the side splitters, because if you have multiple things that are parallel, all those sides are split proportionally. So let's take a look. This is wrong. FYI, this should be DF. Sorry about that. I don't know that I changed that on your sheet, so I shall go and check for next year when I'm done here. So let's see what it is. DF over DE. So DF, the whole long thing, over DE, the little thing. So DF over DE. DF over DE. So that should be equal to AC over AB. You guys see that? Because I did this whole long side over the little side. Then I got to do the whole long side over the little side. Let's look at the next one. Get rid of the red. Okay, so EF, so this right here, over DE. Okay, so the two parts. EF over DE should be equal to BC over BA. Yep. So I'm just going to look. It was EF. Yeah, so BC. Find the length of the altitude of a hypotenuse. Oh, this is a great one. Okay. Okay, people. You have to write a triangle. So when you start writing a triangle, first draw your nice straight right angle here. Okay, and draw it so that one length is clearly longer than the other. That helps visually. Then we want to draw the altitude down. You say, where to draw the altitude? Well, it's got to be perpendicular to this side. So it's got to be somewhere. I'm just going to keep this perpendicular where it hits that corner. Boom, right there. So I'm going to draw it straight down, and that's going to be my other right angle. So let's check it out. Find the length of the altitude of the hypotenuse. Okay, so where is that? Because that's what we're trying to find. Okay, that's right here. That's the altitude. The length of the altitude to the hypotenuse of a right triangle. The length of the altitude to the hypotenuse of a right triangle. It's a lot. Whose sides, okay, so we're still talking about this big triangle here, whose sides, not hypotenuse, is 6.8 and 10. So they give you this side and this side. The altitude to the hypotenuse, the altitude to the hypotenuse separates the hypotenuse into two parts, right here and right here. The smaller part is 3.8. Round your answer to the nearest tenth. Okay, so let's go back to what we're finding. This. Well, this is a geometric mean, but I don't have this other part here. So that's really not helpful to use geometric mean. And this is a geometric mean to this and this, and this is to this and this. I need that though. So since the geometric mean doesn't work, what else do we think of, folks, when we have a right triangle with two of the three sides given? Pythagorean theorem. A squared plus B squared equals C squared. I hope you have sweet dreams about Pythagorean theorem. These two are the legs. Where are the legs here? X is a leg and 3.8 is a leg. Squared equals the hypotenuse, 6.8 squared. So we need to solve that. 3.8 squared, let's see what it is, 3.8. 14.44, 6.8 squared, 46.24, minus 1444, minus 1444, x squared equals 31.8. I need to then get rid of the square, so I square root. It's usually plus or minus, but since I'm talking about a length, I'm just going with a plus. I'm going to push the square root of that, and it comes out to 5.639. But it does say round to the nearest tenth. And because if you are a forgetful person, this is already highlighted so that you don't forget. And we round to the nearest tenth. Where's the tenths place? Right here. I look at the number after it. It's less than 5. My answer is 5.6. Is there a unit? No. 5.6. You can put unit if you want. Wow, this is like record video, but you guys are going to want me to do them at school more often, aren't you? The last one here, and it's only 36 minutes. Okay, so let's get it set up. Statement, reason, given, there's 1 point, don't forget it. Okay, wow, we don't have much to go on here, do we? But we can mark these two A, B, C. Make sure you get the right angle. A, B, C. That's this angle right here. Is congruent to ACD. ACD. This angle, not the big angle. Okay. Look at what you're trying to prove. ABC, the big triangle, is similar to ACD. Okay, right now we have one angle. It's not feeling real hopeful. But when it's not feeling real hopeful, we look and see for those things that we can tell by looking at a picture. Vertical angles is one. Do we have vertical angles? No, we have no vertical angles. The other one's reflexive. Do we have any sides or angles that overlap in both of those triangles? Don't know. I shall use my pink and my red highlighter and do something so cool. Ready? I'm going to highlight this triangle. That's one triangle. I'm going to highlight the other. Where is the orange? Where's the orange, people? I hope you see it. The orange is all this, which basically is telling you it doesn't go through, right? It's not going through here. I don't have a whole side that overlaps or anything. But I do have a side here that overlaps. But that's not going to be enough to seal the deal. But what I do have is this angle. That angle is the same. That angle is in this triangle, and it's in this triangle. So I can say this is the same. So 2, angle A, and I can say angle A because there's no other option. Angle A is congruent to angle A by reflexive property, congruence. Now I have two angles. This triangle has 1, 2 that are the same as 1, 2. So I can write my proof statement. Angle, sorry about that A, that is a wicked looking A. All right, angle A postulate. Okay. just as a bonus, I'm going to go back up here and try this one with the mean so that we can see how that works out. Or no, using Pythagorean theorem. So we did this as, this was the mean, 2, 3, and x plus 3, and that worked fine. But you could also get this height by doing 3 squared plus the altitude squared equals 6 squared. 9 plus a squared equals 36 minus 9 minus 9. That is square root of 9. I'm just going to do this fast. 3 root 3. Oh, you can see this will be much more fun. 3 root 3 is that. So now we can do geometric mean. That's my geometric mean. 3 root 3, 3 root 3. And then my two sides are x and 3. Multiply. 3x equals 3 times 3 is 9 times square root of 3 times square root of 3 is square root of 9, which is 3. 3x equals 27. Hallelujah, hallelujah, hallelujah. It's the same. Isn't that cool? Come on. That is so cool. That is why math is so flippin' fun. All right. Hope you guys are ready for this test. You know, it seems like it was a short chapter, so you just got to hone in and make sure you have all these different little concepts right, and you should be good to go. All right, and 42 minutes later, it's a record. Take care. Have a good day.